will be due next Thursday, okay, on your law of sines. And we will then transition to the law of cosines. So you may want to get in your text and pre-read the law of cosines section in your text. It's a pretty short little section, but that is where we are going next week. All right, so let's use the cheat sheet as a review for the law of sines. Remember, whenever you have a triangle of some sort, the first question you need to ask yourself is, what?
A right angle or an oblique angle?
Exactly. Is it a right triangle or is it an oblique triangle? Because when we get to the end of this thing, we're going to have 10 different equations to work. A right triangle has 4 equations that work with it. Pythagorean theorem and SOHCAHTOA. There's 3 of them there, right? That's 4. Law of sines has 3 equations in it. Law of cosines, which is right above here on the cheat sheet, also has 3. So on obliques, you're going to have 6 equations to choose from. And really what we're trying to do here is narrow it down so that we get to the right equation to use it. So the first question is always, oblique or right? So once you determine it's an oblique, then we'll come down into here and we'll dive into our known information. And if we have as known information, we have 2 angles and a side, then we know we are using the law of sines to solve for that triangle. Now, when I say I've got 2 angles and a side, do you remember what else we know about this? Yes, Declan?
If you subtract the 2 angles, you get the third angle.
Yeah.
From 180.
We really know all 3 angles in this situation, right? Because all triangles have 180 degrees in them. So 2 angles and a side. Also, if we know 2 sides and 1 angle, but the angle has to be opposite one of those angles. Okay? Or, excuse me, I said that backwards. Your angle has to be opposite one of your known sides. Then we're using the law of sines. Now that's 2 of the 4 possible combinations that we can know out of an oblique triangle. When we go to the law of sines next week, we're going to go into those last 2 possible combinations. Okay? So that's all we need to know at this point. Now the big trick with this, again, is do you label your triangle correctly? Okay, we changed it from a right triangle where we labeled it as hypotenuse, opposite, or adjacent sides. Or the Pythagorean theorem where we called our legs A, B, and the hypotenuse C. Now what we are labeling them as A, B, or C, capital letters for angles. The important part is that the side with the same letter must be opposite. So if I call this angle A, doesn't matter if I use this corner, this corner, or this corner. I can label anything I want A. What matters is the side opposite must have the same letter. And it would be lowercase. So I just take them and run with it. That then comes into our equation. We set 2 of these equal to each other. So again, you can go A is equal to B, B is equal to C, or C is equal to A, any of that. As long as you know 3 of the 4, you can solve for an indeterminate. Any questions on what I've talked about so far? Okay, let's put it in practice for a quick example. Since we're doing elevations and we're drawing trusses this morning, I thought let's bring a truss question in. So here I have a dual pitch truss. If you remember that from your architectural text, when I have a dual pitch truss, that means one side is going to slope at one, rise over run, and the other at the other one. So I went down and put my interior angles on here. Now we can come off of a floor plan and we can measure our horizontal distance that this truss will span. In this case, it's 15 feet. What I would like to do is solve for what this top plate or the rafter of this truss needs to be. So we basically lay that out. I'm going to real quickly give myself a little white space here. We'll leave that up on top. So once we get this, I would suggest that you immediately rewrite your equation, get rid of all your nonsense. So I know I'm 80, 60, 40, and 15 feet. Okay. Now at this point, we want to label our triangle. Okay. So I'll just pick one. Let's see. Last time I picked, you guys kind of got on me. Is it okay to go A here?
Yeah.
Okay, there's A. A, and we'll go B up here. That means this side's B, there's C, and there's little c. So this is our given scenario. Now we're going to move into our find scenario, or we're going to develop our outline. Where are we going? Okay. What are we looking for? Which
Little
one
a
of
and
those?
little a and little c, right?
Technically, we'd probably look for both rafters. For this example, I only want to look for this one. Okay? So we're going to look for side C. Okay? That's what we're looking for. Again, a foolproof way to know which one I'm looking at here is to take this information, write out your law of sines, mark off what you know, mark off what you're looking for, and that will pretty much tell you the equation you're using. So I know side B, so I'm going to put squares around stuff I know. I know all three angles. And I'm looking for side C, and I'll use a revision cloud for that. Now, in essence, doesn't that tell me what my equation is going to be? Majed, what would you use for this?
The equation,
Yes.
so it will be b, small b, over sine 80.
Okay, I'll just write it as the angle for right now, but we'll put our numbers in a second.
Okay, so small c.
Okay, good, you got it. Okay, so here's our equation. Okay. Folks, this method will work for you every single time. Remember, you have to know 3 of the 4. If you don't know 3 of the 4, what do you need to do?
Call
Come
your
on the
trust
job.
manufacturer and yell at them.
Or you go out and physically measure it yourself if you have that capability. You can call a contractor, you can call a vendor, and maybe get some of this information if it's some machine or part that you have bought. So we might have to do a little research to get enough information here.
Turn it into a right triangle.
There you go. All right, so let's go ahead and plug in our numbers. B is, one of these days I'll bring some real pens. 15 over the sine of 80 is equal to C over the sine of 60 degrees. Now again, you can reduce this to a number and this to a number if you wish at this point. Go to 2 decimal places. I'm going to go ahead and isolate my variable first, and then we'll do the math second. So I've got C in the numerator, that's good. Now I need to get it by itself on the same side. So I'm going to come over here and times by sine of 60. What I do to one side, I got to do the other, right? This goes to 1. In essence, we call it canceling out, but it's 1. So I'm left with the sine of 60 degrees times 15 divided by the sine of 80 is equal to side C. At this point, we're ready to plug and chug. Okay, so we go to the calculator. Jess, when you get an answer for this, will you let me know what you got? Oh, yeah, that's right. We'll save your voice on this one. Juan, how about you? When you get the answer, can you let me know what you get?
Okay, right.
Okay, what'd you get? 11. Exactly.
0.25.
0.25. And that's feet. Can I get somebody to confirm that answer?
I didn't get that.
Okay. What'd you get, Andy?
I got 13.32.
Okay, so
That's
now
what I got.
13.32, you said?
Yes.
And we've got that one confirmed?
Yeah.
13.32.
13.32. So Juan, when you plug that in, let's make sure you can get that. Let's just run your calculator real quick. Let's make sure we got it. So on your visibility equations. Sine 60. Times. And this will be 15 equals. Oh, you gotta put the bracket on the backside of the 60. Finish that. Then you're gonna say divide sine 80. You did sine first. You gotta put in a function, then you agree, and then hit equal, and it should give it to you. Are you now at 13?
Yeah.
Okay. All right, any questions on what we did here?
So I got 13.19, so is it because there's a degree of variance? Or
Is that
Yeah.
because of how
Same
we all
answer.
rounded?
Same answer, it depends on your,
You did? Okay.
yeah, it depends on how many decimal places your calculator carries or where you write them down,
Okay.
okay? Again, I'm gonna hold you to 2 in here, okay? And yes, we'll have a wide range, because some people are, what are you carrying, 5, 6 decimal places on that calculator?
Yeah, I just rounded up, like before I even.
Okay, so you rounded 2 right off the bat.
Mm-hmm.
Ben, what'd you get?
13.19.
13.19. And
That's
how
right.
many decimal places you carry in?
I'm out like 10.
Okay,
See, I actually did the fraction.
okay. I need you accurate to 2 decimal places in here. Okay. If you're, the 1.9 is more accurate than this, right? But they're both right. They're both right. Are we good with all that? Think so? Okay, great. Let's see.
Oh, damn it.
You wanna go first, Cheryl? Okay, I'm gonna let you try since you're participating in the class today. I will put the cheat sheet up on the board, or you may use your phone. If you would, please read through this, solve it, put it in the wire basket. When you're done, you have 10 minutes.
We use the computer tool.
Yeah.
But I can.
Why does your banana have like a little hat on?
Oh, because it was already on it.
A
They're special.
You don't understand
hippie
what's
banana.
Special banana.
So I got people going.
Sorry.
About 2 more minutes, folks. I don't see anybody else still working. Has everybody got turned in? Regardless of how you do on this, let's just go ahead and talk about it real quick and see if we came to the same result. So in essence, I ended up deciding that this angle was 100 degrees. Did everybody manage to get that? This is 100, this is 39.75, so you take 180 minus this comes up to 40.25 degrees. It's this triangle here, got rid of the nonsense, I do know 100 feet. Okay, so based on how you labeled it, you might have different down here, but ultimately what you should have is 100 over sine 40.25 is equal to A over 39.75. You might have had that a different side, right? The final result, once you finish your math, is 98.97 feet. Any questions how I got any of those numbers up there? All good? Hunky dory? Okay. We'll get those back to you as quick as we can. I tried finding in the room something we could measure and put this to real life, and it was raining, so couldn't really find anything. We got a good law of cosines example sitting in this room, so we'll save it for that. So I want to do some sample problems, just to make sure you got some examples that you can use into your assignment. Now, before I do that, I do want to give you an opportunity on your law of sines homework. Are there any of the setup problems you wish me to review? Again, I'll help you with any setup as we come through story problems. I won't do the math for you. Missy, I made a point of saying story problems.
Yeah.
Real life problems. I found my little cartoon. I don't know if this has always been one of my favorite cartoons of all time. If you can't see in the back, so you got the pearly gates here, right? It says, okay, now listen up. Nobody gets in here without answering the following question. A train leaves Philadelphia at 1 o'clock. It's traveling 65 miles per hour. After another train leaves Denver at 4, blah, blah. Say, you need some paper? It's always been one of my favorites.
And that guy looks so happy.
Yeah. The cartoon is labeled A Math Phobia's Nightmare. Anyway, I like that. So on your homework, any of these that you wish to review the setup? And make sure you got it right so you can accurately solve these equations. Let's just go through them. Number 1, number 2, 3, 4, 5, 6, 7, 8.
8.
Declan? 6. Okay, let's look at 6. Ah, just exactly what that old guy was sitting up there with St. Peter. Town B is 28.3 miles south of west of Town A. Didn't we just do this one at your desk?
No, yesterday we did.
Oh, this is the one me and you worked for. Okay, Majid. Town B is 28.3 south of west. Thank you, Majid. I'll get it right today. Determine the heading of a plane traveling to A to B if the wind is 38 miles per hour from the east and the plane speeds 400 miles per hour with respect to the wind. Okay, so initially let's set up the scenario here. And this happens every single day a plane takes off, especially in southern Idaho. So in essence, what we have is we have 2 towns. I got town A here. I have town B down here. Now we're given the heading. We know town B is 28.3, and you pay attention, excuse me, to the detail of how they tell you this. 28.3 south of west. Okay. Where's west on any map?
Down and to the
Left, right? Okay. So we know that this direction is west. And what they're saying is you're going to turn 28.3 to the south of the west line. Okay, so I'm going to draw this line in right here. And what it tells me is this angle is 28.3.
Oh.
Now, then it says you have some wind blowing from the east, so it's blowing east to west, and it's blowing at 38 miles per hour. Okay. So I'm just going to put a little vector down here. This is actually a vector diagram. 38.5, did I get that right? 38 even. And that is miles per hour. Okay. The plane speed will be 400 miles per hour with respect to the air. Okay. So that is going to be this leg right here. That's 400. Now, we do use a lot of vector diagrams. You're going to see this again in architectural when we analyze trusses. We used right angle trigonometry.